Okay, so there are two topics for today. The first is exceptions. And, you know, we've kind of encountered exceptions as we've been going along. And we'll talk about how there are two different types of exceptions, checked and unchecked. And I'll talk about what the difference of those are, how to handle exceptions. There are basically two ways to handle an exception. One is through try catch, which again, we have seen a bit, and the other is through throws. So it depends on whether you want to be a, well, it's kind of a judgment call, but just to kind of put a little bit of spin on it, it depends on whether you want to be take responsibility or pass the buck, or an example of the programming virtue of that's not my job. So, and then this finally, which we have seen examples of, and what's that about and how does that work? What happens if we don't catch exceptions? You've all seen examples of that, and then after we do that, I'll show you what logging is about. And logging is really the right way to use what we've been, or what you may have been doing, using print line statements for. So remember the dictum about in a component, meaning a class that you're going to create instances of, it is generally not a very good idea to put a print line statement in. However, putting logging statements in can serve the same function and are very good about, well, much more flexible, as we'll see. Okay, exception types. There are two, checked and unchecked, and it's important to understand the difference. The terminology is a little bit strange, to be honest. I found it strange when I first encountered it, but then when I understood why they were called that, then it started to make sense. Practically speaking, a checked exception is one that you have to either do a try catch or a throws. You just have to. There's no getting around that. Why is it called checked? It's called checked because it is checked at runtime. In other words, at it's actually checked at compile time. So so that I should have, this should say compile. Okay, so what happens at compile time, and this is in compile. All right, so what does that mean? That means, in essence, that if you don't do it right, you get a red squiggly. And we've seen examples of that when we have written a statement that invoked a method that could have thrown a checked exception, then we were offered basically two options. One is to put a try catch around it, which is in almost all cases what we've decided to do, or add a throw statement to the method, which we've generally not decided to do, again, because my rule of thumb is that in general, you should catch the exception rather than throw it. There are exceptions to that, of course, but the idea is that a checked one is, again, it's checked at compile time, which means that it's not even going to let you run until you have demonstrated through the code that you are handling the exception. And if you don't, then you get the red squiggly and the program won't even run. So again, a checked exception has to be either caught or thrown. Some of the examples we've seen of that are a file not found exception when we were dealing with the file system, an IO exception when we were either reading or some writing to the file system. We saw when we were connecting to URLs, there was a malformed URL exception. And those are all checked exceptions, and we have to explicitly deal with that. And NetBeans is very good at sort of gently letting us know that via the red squigglies that something needs to happen, or if not in that case, it's usually not a red squiggly. It's like a little red dot to the left, and we've seen those. So those are the checked ones, and we've seen how we deal with that. The unchecked ones, the main unchecked exception we have dealt with, or you have experienced, is the null pointer exception. So the null pointer exception it's not a checked exception, because how do we know that? Well, because it will show up when we run a program, even when we haven't tried and caught it. Now, it is completely possible and sometimes desirable to explicitly have a try catch around an unchecked exception, such as null pointer exception. More commonly, what we want to do is what we've done. I think we'll see an example of this in some of the code today, where, well, when we were dealing with the scanner, if you remember, that when we because the scanner had checked exceptions, what we did is we declared the scanner variable outside of the try-catch loop, so that when we had that finally piece, what we did was we just had a test to see if the scanner was null, not null, then we would close it. And if it was null, that meant that something had happened. Okay, so unchecked, and there are other unchecked exceptions, and in general, there's an exception called a runtime exception, which you can always kind of throw. So again, checked versus unchecked. So to catch an exception, we use the try catch. So here's an example. So, and we've seen this. So now here, of course, this doesn't do that finally thing that we did before. This was kind of the first cut at this. So the issue with this was that we're kind of closing the scanner within the try catch loop. When we instantiate a scanner, if you look at the code for scanner or the Java doc, you will see that it throws a file not found exception when we get a file. Why? Because does that make sense? It absolutely does, because if we're asking the scanner to scan a file that doesn't exist, then anything we do after that, anything we're doing in here to read that contents, has no chance of succeeding whatsoever. Close you up here. All right, so what NetBeans suggested, and then NetBeans, when we say surround it with try catch, what it does is it writes this statement here, which will show kind of a slightly cleaner way to show that, but it's kind of a the idea is that we're going to log the exception. That's basically all it does, and we'll see more about that. So now throwing exception is the other option. So remember, NetBeans gives us this option of catching or throwing, and if we decide to throw it, that's again, sometimes it's desirable. So the scanner constructor throws a file not found exception, and if you look at the definition of that, then it's right there in the definition. Now we could have rethrown that. We could have actually rethrown that in main. So instead of doing the try catch thing, we could have simply said we could have simply said this. If you're kind of in a hurry and just kind of throwing stuff together, or maybe just for a demonstration purpose and you don't want to do a whole lot of typing, that can be sort of useful. In general, it's not, throwing exceptions from main is not the best idea. Why? Because there's nothing to catch it. If this exception actually gets thrown, then you get all that red stuff and in the console. And that's not an ideal thing to happen. So when they were defining the scanner class and the scanner constructor, though, it was a good idea to explicitly throw this exception, because the scanner constructor has really no way of knowing, or it doesn't know how you want to deal with the fact that that you may be trying to scan a file that's not there. In other words, the scanner class doesn't know what you want to do, what the user wants to do. So if this is embedded in a graphical user interface, for example, and you, and you try to scan a file that's not there, that throws the file not found exception, what you might want to do is just throw a pop-up dialog, which you've probably encountered something similar in other applications, as, hey, this file isn't found, pick another one. So again, the scanner class doesn't know how you want to handle this. And so it's just going to say, look, I'm going to throw a file not found exception, and it's going to be up to you to deal with it. So that's an appropriate use of the virtue of that's not my job. Okay, and finally, we have the finally block. And the finally, the thing about the try catch, see what happens in a try catch is that if, depending on what happens in the catch, it could be that execution may or may not proceed from that point. We simply don't know. The finally block is always executed in the try catch, regardless of whether the exception has occurred. And we've seen that with ensuring that the scanner class is closed. So this code block here, which would be a first cut at it, is not the ideal way to do it. A better way would be to define this outside of the try catch block and then have a finally block here that makes sure it's closed. Okay, why? Because the scanner is in setting up the scanner here under the hood, it's opening up and seizing a system resource. And if the program exits without closing all of the system resources, then they could sort of be still held on to. So that's where the finally, you notice that at first, as a first cut, we did this, but then after a while, we had this finally one where we said, okay, if the scanner is not null, then we'll make sure it gets closed. And that ensures that the scanner will always close regardless of whether an exception is thrown. That's important. That's also important when we're doing things like interacting with databases, so a connection to a database, again, that will typically consume system resources. And if we have a lot of them, it can consume a lot of system resources. And you want to make sure that the program releases those system resources. So that's what the finally block does. Okay, now the danger of uncaught runtime exception. So now what happens if you have a runaway exception? Now that can only happen to a runtime or unchecked exception. Why? Because, it typically, it kind of depends on what you do. If you start throwing the exceptions, then again, they can just kind of keep bubbling up. What happens to them? Well, we've kind of seen what happens to them, which is, again, with the null pointer exception. What happens is the program just kind of blurfs. The program blows up. So what happens is that when you have a runtime exception, or actually any kind of exception, but typically with a runtime exception, null pointer exception being the most common, what happens is it just keeps going. When I say going, it just keeps bubbling up through the call stack. It goes, there's usually a sequence of methods that have been called to result in this. So what it'll do is it'll bounce back to the calling method and say, are you going to catch me? Because you can catch it. And if you don't, it'll go back to the calling method of that, and it will keep going until it reaches main. And when it reaches main, if it doesn't get caught, it gets thrown out of main, And then that's when you get all that sea of red and the basic link. So when the program bombs, then what's happened is a runtime exception or some exception has just kind of percolated up and not been caught by anybody. That is not a good place to be when in a program. If you're running a program of some software that you bought and it just kind of blows up on you, and typically with a graphical user interface type of program, you don't have a console that has all this stuff on it, but it just stops working, then that's not a good state of affairs. So you generally don't want to do that, and you want to have make your programs as bulletproof as possible. Again, ideally, you never have these exceptions. In practice, for a program of above a given size, there are going to be situations where this occurs, and there's oftentimes things that the user does that you want to make sure that can cause an exceptional condition. You want to make sure that gets taken care of. Okay, so let me, before I move to the next topic, yeah, I haven't gone through any specific code for this, just because we've seen all this before, and we're going to see it. Well, we've seen it again. We can kind of look at that in the logging that we're going to talk about. So are there any questions about exceptions? Because this should all be, with each of these, this should hopefully at least explain things that you've already encountered. Okay, so now let's talk about logging. Okay. So far, what's happened is that when NetBeans has added a try catch, they've had that that business of there's that big long line of things. Now, when it comes to using logging, there's a slightly better way, and that is to explain it, to obtain an explicit logging instance for each class. And that's actually what the NetBeans code was doing, but it was kind of doing it in a kind of an ad hoc way. So what a logging instance is it is typically done as a static variable. And then we use that static variable to log various things. And we'll see an example of this. Now, the thing about logging is that it can be used to either produce a sort of a comment-like thing, or notification, basically what we've been sometimes using printline for, and that would be an info. There could be a situation where if certain things happen, it's not quite an error, but it could be. And so there sometimes you want to kind of warn the user, says, hey, you're about, if you're here, then something weird is happening. And then severe is basically an error. So if you notice that in the try catch that NetBeans, the logging statement that NetBeans put, it always was severe. And we'll see an example of that. Now there's fine, there's actually fine, finer, finest. There may be a couple more that I'm not remembering here. What fine is like a debugging statement. In other words, when you're developing a program, and this is something that you probably have done in the past, which is as you're developing the program, you want to make sure, okay, I'm here, etc. And we actually saw this yesterday, where there, as was commented in the callable, there was a print line statement to say, okay, I'm here and I'm doing this. And as I said earlier, that's not a good practice. It was something that was just done for demonstration purposes. However, that's where something like a fine comment can be made. And the reason for this is because with a configuration file, a properties file that we'll see, we can control which of these statements actually get printed. And what we're just going to kind of dip our toes into this a little bit, just enough to be a little bit dangerous, but hopefully useful. The idea is that we can configure this properties file to tell us how many of these warnings how many of these logs to actually do. Okay, so, and we'll see what things are about. The syntax of this properties file, it's almost like a little language of its own. Unfortunately, it's not terribly well documented. Fortunately, Java provides an example that can be easily tweaked to what we need, and we'll see an example of that. There are a couple ways that we can set this up. We can either load this file directly in the program, or we can give it as a virtual machine option. And we haven't dealt with virtual machine options yet, but I will show you how that is. And that's this -d says basically add this thing that follows, which is going to be a string equals another string, to add that to the system properties. And then for this particular value, Java util logging config file, that will tell the logger to read this file and configure the logger. Okay, so now what's in that configuration file? Well, basically handlers and formatters. So what a handler is a handler tells you where it's going to put stuff. There are basically two that we'll deal with. One is a console handler. And so a console handler writes to the console. What the console is basically the command line. And then we'll see what the file handler is about. The file handler will write to a log file. The advantage of that is that when we're running things, you may have noticed that whenever you run another program, it erases and then overwrites whatever was in the console previously. If we have a file handler, we can write it to a log file, and then it has a kind of a nice way of rotating those files. So it basically saves whatever was logged so we can take a look at it later. There are two basic ways of formatting. One is a simple formatter, which is just a one line, and then there's a really nice one if you're kind of into XML, which formats the log as an XML file, and we'll see an example of that. And then we can give specific levels. So the levels are specified as we'll see. Okay, so let's see what that's about. And I need to share my whole screen to do that. Okay, so let's see, where should I put this? I'm just gonna, it's just gonna be one file. So I'll put it in run here. So now before, we don't even need to run to deal with the configuration file, because by default, it'll just do stuff to the console. So let's just see what that's about. Okay, first to define a log file, a log instance specifically for this class is, we'll typically define a private static final. Final is actually redundant if it's private, but the class is called logger. Because it's a Okay, here's darn it, it keeps giving me the wrong one. Okay, so let's okay, never read. Okay, so this is the pattern for defining a logger for this class. A private, I mean, just because you want each class will have its own logger. And the reason for that is so that when it logs it, it'll sort of automatically tell you where it was from. Okay, static, meaning that it will work for all instances, so you don't have to create a separate instance for each one. Final, because you don't want to, you know, you don't want to create any new ones. Okay, logger is the type. It is from the Java util logging package. Okay, logger, all caps, that's because it's a static final variable. It's all caps. Logger is what I often use. You can use whatever you want. And then the way you get it is, rather than instantiating it, you use, again, this factory method like thing, because again, notice logger, a class, get logger, so that tells you it's a static method. And because it's returning an object, it's a special kind of static method called a factory method. You don't have to remember that. But what you pass it, and there are a number of different options to pass. For this, it wants a string, and you will typically, or the pattern that is most useful is the name of the class dot class and then get name, and that will ensure that the logger kind of knows where things are. All right, so let's sort of see what that's about. So okay, so the way to use it is it has many instance methods that will tell you what level there were, and there are all kinds of ways of configuring it and stuff. We don't have to worry about that. But if I want an informational message, and let's just run that. See that again without any configuration. Notice by default what it does here. It tells us the time, actually the date time. It tells us the full name of the class that it was from, and that's because we gave it right here. And then it tells us what the method was. So this was in the main method, and then it said info. If I want to give another type of message, what if I want to give a warning? Then again, notice that it kind of gives, it tells us what type of message it is. Okay, so a severe is basically an error. That means that this is so bad that we just kind of got to go. Okay, now there are others. Remember we said that there was a fine. And notice that, okay, notice that the fine message did not get printed. Okay, why was that? That is because without a configuration file, it will only print info, warning, and severe messages. And what that should tell you is that if I want to put debugging messages in my code, then I can do that with a fine log. In other words, instead of putting a print line that I'm going to have to later take out, if I want to put debugging statements in, say, okay, I'm here, now I'm here. If I put those in as a fine log, then with the configuration file that we're about to see, I can turn those on and I can turn those off. Again, the default, what's happening here is it's using some kind of default console logger, and the default level is at the info level. Okay, so now where is that coming from? So if we want to do things like turn this on, well, let's let's do an exception. Okay, so all right, so now how, like if I want to throw my own exceptions, and we're not going to be doing that in this course, but I mean, in an advanced course, you would, in writing a larger application, there may be times when you want to create special exceptions to convey something that goes wrong with that. So here now we're catching it. So what we would typically do oops, if I want to say, all right, so now I've caught the exception. See, now if I run that, then it says the exception was caught. And then, remember I mentioned the finally, which we've seen. Okay, what finally does is regardless of what happens inside this exception here, then this will always get executed. Okay, so we see it here. So even, and what I'm going to do now, remember, like as I said before, when we catch an exception, we have a couple of choices. One is I can simply say, oh, that was really bad, naughty, naughty, or I could, we can actually chain these exceptions like this. So I can actually throw, oops, another runtime exception. So I'm passing the buck here. And that now I'm going to get a bunch of red stuff and really bad things, but just to show, okay, so bad stuff here. Why? Because when I threw this exception from main, there was nothing to catch it. But then notice, see this statement right there. Okay, so even though right here, even though the exception got thrown because of the finally, it was always there. So with that, the power of this finally is that now I have one last chance, even if the program is just going to blow up, I have one last chance to do that. Okay. Now we're back to this. All right. Now, what about that logging file? So here's the thing: is that the syntax of it is a bit flaky, but what we can do is let's Java provides a default one, which is what was being used for this. So where can we find that? It's in our Java platforms. So what you can do is if you do, okay, what was I doing? If I do tools, Java platforms, you can do this to find yours. And in your, if you're running JDK 11, as we are here, if you select the platform folder, do a copy. Okay, I just did a Command C because I'm on a Mac. I'll show it to you on Windows in just a second. And then if I open up a terminal and I type open and then I do a Command V, I hope you're all seeing this, right? Okay, so that's taking me to the Java virtual, the JDK that I installed. And in that is a conf directory. And in that conf directory is a file called logging properties. So if I just simply copy that and just paste it into the root of my project, we'll see that if I move to the Files tab, delete this, that was okay, and there it is. This is it's a text file, and this is the default one that Java provides, and it has pretty much most of the things that we can use. Now, if you're on Windows, it's a similar thing. It's the same file. On Windows, it's going to look like this. If we, again, tools, Java platforms, again, if I just select all this, I do now a Control C and close. And then if I open up a command prompt and I type in Explorer space and then do a right click and then enter, it will open up to where the JDK is. There's also a conf directory there. And then there's my logging properties. I can copy that. And then let's see, where are you located? Yeah, the Windows thing keeps putting in this OneDrive place. Let's see, it was in, where was it? Documents, NetBeans projects, there, and then I right click and paste it in, and there it is. Okay, so on Windows, that's how you do it. So back to the world. Okay, so let's take a look at what's inside here. So we have handlers. So by default, it just lists says a console handler, but then it says to add the file handler, use the following line instead. All right, so we'll come back to that. But here, limit the messages that are printed to info and above. So here what we can do is if we change this to, let's say, severe, then when I run it, it will only print, it should have only printed, because I'm not pointing to it. It was still using the default one. Okay, so now how do I do that? I need to put it on the command line, and to do that, I need to do one of these guys. So let's do a new one of these. Browse to, where was I putting it? Test logging. Right, so what I want to put in the VM options is -D java.util logging config file, oops, equals, no space, logging properties. Okay, what that is that's the same name as I have over here. Okay, and remember, okay, so what have I done? I've changed the level of the console handler to severe, and so it should only print the severe messages. If I change, now notice that it was originally at info, and so at info, it prints all the info, warning, and severe, but it did not print this fine one. So how can I do that? Well, I can actually change it to fine. No, I have to change it to all. Right, maybe I have to change this one to all. There we go. Okay, so there's the fine one. This should have done that, but okay. So now the final thing that I want to talk about today is just putting this in a log file. Now, what they do by default is they put it in your home directory, which is what this is about, and that is not the ideal thing. What I prefer is to actually put it in a log file like this. Let's make that 5. And then what I need to do is I need to ensure that that log directory exists, because now, and then I also need to, let's comment this and let's uncomment the handler. So now I have a file handler and a console handler. So the file handler is going to put them in a file called java.log. We don't need to, this count though, what that's going to do is that's going to save up to 5 copies of the log file. And it's going to be, well, just to kind of keep things simple, let's keep it a simple formatter. And then now, okay, now I'm going to get an error. It's because what it's going to say is it's going to say the log directory doesn't exist, is what the problem is. Okay, so the easiest way is to create a new folder called log. And again, I need to do this in the Files tab. And now when I have that and I run it in my log, I now have java.log.0. Okay, that's the first one. Now notice that, okay, info, warning, severe, fine, severe, and info. Okay, and what I can do is I can, let's see, where is it? The file handler level. I didn't set the level. I can say, usually having all of them is a good idea for that. Okay, now notice what happens when I run again. If I run it again, what it did was it took the previous file, the 0 one, and it copied it to 1, and then wrote a new one. Okay, so let's prove that that was the case. Let's run it again, and for the file, let's only put the info ones in. Or actually, let's put the severe ones in. So now when we run it, the new one only has severe messages. The console has all of them. And this was the previous one. Okay, so what it does is every time we run it, So let's, if I change this to info, then, so now it has the info, warning, and severe, but not the fine. If I change this to all, then now I'm back to all. Okay, now notice that it's given me up 0 through 4, so it's given me 5 of them. That's because when I said count was 5. Now when I run it again, it still only gives me 4. In other words, the one that was 4 kind of rolled off the end. So there's a rotating set of those. And I can change this number to anything I want. If I make that 100, then it'll keep up to 100 log files. So what's useful about that is that usually 10 is about all I've ever needed, but especially if you're debugging a program, then you will typically want to, there'll be things that show up in your log file that you want to look at and work on until it is exactly the way that you want. And so when that is the case, when things are working the way that you want, then you can, it's typical to then change the level to severe rather than for the console, so severe. For the log, info is usually kind of useful, and because if I have these fine ones in, then they get skipped, but at least I have the info ones, and that can also often be useful. Okay, so that's a bit of a sprint through logging, and tomorrow I'll do a little bit more with that, but tomorrow we're going to start talking about inner classes, and what we're preparing for is to start working with the graphical user interfaces with Java. The things that we need to know for that, in addition to all the stuff we've been learning so far, include things like, well, threading is important for that. And the inner classes that we'll talk about tomorrow is another element that we're going to need in order to make our programs live. So that's it for today. And if there are no further questions or comments, we will see you tomorrow.